Hello and welcome back to Engineers Olympiad, where learning meets success. This video lecture is the continuation of the previous video lectures which are held on the topic Introduction and the Basic Concepts of Surveying. And you can watch those videos before watching this video. So let's begin. Types of measuring scales. A measuring scale or a plotting scale is required for preparation of plans and for measuring distances from the plans. These measuring scales, or they're also known as plotting scales. These are used for preparation of plans and for measuring distances from the plans. Right? And students, please do not confuse yourself. This is entirely different thing than the scale of a map, which was discussed in the previous video lecture, wherein I told you that the scale of the map is a ratio that every distance on the map bears to the corresponding distance on the ground. But the scale of the map and the measuring scale or a plotting scale, these are two different things, and please do not confuse yourself. So these are used for measuring, for preparation of plans and for measuring distances from the plans. Right? We use these plotting scales or these diagonal scales in preparation of plans and in measuring distances from the plans. And we have three types of measuring scales: a plane scale, a diagonal scale, and a chord scale. We have a plane scale, a chord scale, and a diagonal scale. Right? And a good scale must satisfy some requirements. Let me write it down for you. What must be a good requirement of a good scale? It should read to the required accuracy. Point number one. Scales, they should read to the desired accuracy. Point number two. They should be of suitable length, generally not longer than 300 mm. Let me write it here. It will be easy for you. Point number one was the requirement of a good scale, that they should measure distance to the desired accuracy. Point number two is that they should be of suitable length, generally not longer than 300 mm. What? A measuring scale or a plotting scale, or 30 centimeters. Not beyond these lengths, right? And the third point, the third requirement of a good scale is that the scale should be accurately divided and numbered. It should be accurately divided and numbered. These are the requirements of a good measuring or a plotting scale. The fourth one is that the scale ratio or representative fraction should be clearly written on the scale. The scale ratio or the representative fraction should be written on the scale. Right? Other requirements, let me write it down here for you. The fifth one is that the main division should preferably represent units, 1/10 of a unit and 1/100th of a unit. The main divisions should preferably measure unit, its submultiple, and further submultiple. Right? And the scale should be convenient to use. The distances should be measured easily, right? And the scale, the sixth requirement of a good measuring or a plotting scale is that it should be convenient to use. So these were some requirements of a good measuring or a plotting scale, which is used for preparation of plans and for measuring distances from the plans. And as discussed, we have three types of scales: a plane scale, a diagonal scale, and a chord scale. Let's discuss them one by one. A plane scale measures some unit and its submultiples. It measures, plane scale, it measures some unit and its submultiple. Right? And diagonal scale, for example, meter and decimeter. Let's suppose meter and decimeter. Right? A diagonal scale can measure a unit, its submultiple, and further submultiple. For example, meter, decimeter, and the centimeter. Right? So diagonal scale reads some unit, its submultiple, and further submultiple. For example, meters, decimeters, and centimeters. So we can measure a unit, its 1/10th part, and its 100th part by using a diagonal scale. Right? And a chord scale. A chord scale is used to measure angles or to set out angles in the field without using a protractor, and these utilize the chord distances of a circular arc. A chord scale utilizes the chord distances of a circular arc, and this chord scale is used to measure angles and to set out angles in the field without using a protractor, right? So this was about the measuring scales. Let's move on and study about the verniers, use of verniers in scales. Very important topic. Use of verniers in scales. So what's a vernier scale? A vernier is a device for measuring accurately the fractional part of the smallest division on the graduated scale. We can measure the fractional part of the smallest division on the main scale by using a vernier scale, right? So the readings are taken much closer than the smallest reading on the graduated scale, that is the main scale, right? And let me rub it first. The vernier makes use of the fact that the human eye can perceive with greater precision when the two lines coincide and form one continuous line, then it can estimate the distance between two parallel lines. Let me summarize it again. A vernier is based on the fact that the human eye can perceive with greater precision when two lines form one continuous line, rather than it can estimate the distance between two parallel lines. This will be emphasized and illustrated in the coming scale wherein I will show you how do we take the readings by employing a vernier scale. And it must also be noted that the divisions on the vernier scale are either slightly shorter or slightly longer than that of the main scale. The divisions on the vernier scale are either slightly shorter or slightly longer than the divisions on the main scale, and that forms the classification of the verniers. And the least count of the instrument is the smallest reading which we can take by that particular instrument. And the least count of the vernier is equal to the difference in length of one division of the main scale and one division of the vernier scale. Right? The least count of the vernier is equal to the difference in length of one division of the main scale and one division of the vernier scale. And according to the divisions on the vernier scale and their length, we have some classification of verniers. The first one is a direct vernier. A direct vernier is a vernier which has divisions which are slightly shorter than that of the main scale, right? So a direct vernier is a vernier whose divisions are slightly shorter than the divisions of the main scale. Right? Let's try to find its least count. Let me rub it first. So a direct vernier is a vernier whose divisions are slightly shorter than the divisions on the main scale. It's a direct vernier. Right? Let's assume that the n divisions on the vernier scale are equal in length to n minus 1 divisions on the main scale. N divisions of vernier scale are in length equivalent to n minus 1 divisions on the main scale, because as already discussed, the direct vernier is a vernier whose divisions are slightly shorter than the divisions on the main scale. Right? For example, we have to find the least count of this direct vernier. How will we find? This V, this is the length of one division on the vernier. Length of one division on the vernier. And this S, this is length of one division on the main scale. Length of one division on the main scale. Right? Let me rub it first. So if we have to find the value of V, this will come equivalent to right? So as already discussed, least count is the difference in length of one division of the main scale and one division of the vernier scale. So least count will be equivalent to S minus V, since S is length of one division on the main scale and V is length of one division on the vernier scale. Least count will be equivalent to, we can substitute this over here, by solving, least count will come equivalent to S by N. Students, please note that the least count of the vernier, of the direct vernier in this case, is equal to value of one smallest division on the main scale divided by the number of divisions on the vernier scale. These are the number of divisions on the vernier scale. This is the length of one division of the vernier scale. These are the number of divisions on the main scale in case of a direct vernier, and this is the length of one division of the main scale, and the least count is equivalent to S by N, the number of the value of the smallest division on the main scale and the total number of divisions on the vernier scale. So a direct vernier is a vernier whose divisions are slightly shorter than the divisions on the main scale, and in this case we assume, let's suppose that the n divisions of the vernier scale were equivalent to n minus 1 divisions of the main scale, and the least count was calculated equivalent to S by N, where S is value of the smallest division on the main scale and N are the number of the divisions on the vernier scale. Smallest value of main scale and number of divisions on the vernier scale. This will be further illustrated when we'll do the numericals on the topic, vernier scales. Right? So this was about the least count. Of a direct vernier. Then we have other type of a vernier that is known as a retrograde vernier. What is a retrograde vernier? A retrograde vernier has divisions which is slightly longer than that of the main scale. Divisions on the vernier scale are longer, slightly longer than the divisions on the main scale. In case of a direct vernier, the divisions on the vernier scale were slightly shorter, but in case of a retrograde vernier, the divisions on the vernier scale are slightly longer than the divisions on the main scale. Right? Let's try to find out the least count of a retrograde vernier. For example, let's assume that n divisions of the vernier scale are equivalent to n plus 1 divisions of the main scale. Right? So NV will come equivalent to n plus 1 S, where V, the same thing, is the length of one division on the vernier, and S is length of one division on the main scale. Right? So we will come equivalent to this. Now least count in this case will be V minus S, because the length of the divisions on the vernier scale are slightly longer than that of the main scale. So least count will come equivalent to, we'll substitute this over here. Same formula in case of a direct vernier. Least count of a retrograde vernier is also equivalent to S by N, wherein S is equivalent to smallest division on the main scale divided by the number of divisions on the vernier scale. And as already told, these things will be further illustrated when we'll do the numericals on the vernier scales. So this was about direct vernier and a retrograde vernier. Then we have some special types of verniers as well. The first one is a double vernier. Special types of verniers. The first one is a double vernier. The second one is a double folded vernier. And the third one is extended vernier. Right? Let's discuss them one by one. Double vernier first. A double vernier is used when the graduations on the main scale are numbered in both the directions. In case of a direct vernier or a retrograde vernier, the graduations are only in one direction. But in case of a double vernier, the graduations on the main scale are numbered in both the directions. Graduations of the main scale are numbered in both directions, right? When the graduations on the main scale are numbered in both the directions, the vernier is known as a double vernier. And the double vernier extends in both the directions and it has the index mark in the center. Index mark is in center in case of a double vernier, and the graduations are in both the directions. Let's study about double folded vernier. These are special types of verniers which are used when we have some special limitations or we want to take some advantages of some situations. Second one is a double folded vernier. What is a double folded vernier? A double folded vernier is a special type of a double vernier whose total length is 1/2 of the combined length of the corresponding double vernier. Right? A double vernier is a vernier which has the graduations on the main scale in both the directions with the index mark in the center. And the double folded vernier is a special type of a double vernier whose total length is 1/2 of the combined length of the corresponding double vernier. This has a length 1/2 of the corresponding double vernier. That's why it's known as a double folded vernier, right? And why is this used? A double folded vernier is used when it's required to keep the length of the vernier short. When we want to keep the length of the vernier short so that we can economize the space, so there we'll use a double folded vernier and not the double vernier because its length will be quite large, and when we want to economize the space, we'll use a double folded vernier, which is a special type of a double vernier whose length is 1/2 of the combined length of the corresponding double vernier. So this was about double folded vernier. And the third type of a special vernier is known as an extended vernier. Extended vernier. What is it? Extended vernier? In an extended vernier, n divisions of the vernier scale are equal in length to 2n minus 1 divisions of the main scale. In case of a direct vernier, n divisions of the vernier scale were equivalent to n minus 1 divisions of the main scale. In case of a retrograde vernier, n divisions of the vernier scale were equivalent to n plus 1 divisions of the main scale. And in case of an extended vernier, which is a special type of a vernier, in this case, n divisions of the vernier scale are equivalent to 2n minus 1 divisions of the mean scale, right? So let's try to find out its least count. n divisions of the vernier scale are equivalent to 2n minus 1 divisions of the main scale, right? So B will come equivalent to, right? And the least count will be equivalent to, please note this, so least count will be equivalent to, we'll substitute this over here, same formula as in case of a direct vernier or a retrograde vernier. Least count is equivalent to S by N, wherein S is the value of the smallest division on the main scale divided by the number of divisions on the vernier scale. So this was about the extended vernier. Least count of direct vernier, least count of retrograde vernier, and the least count of a extended vernier all have the same formula, S by N, where S is smallest division on the main scale and the N are number of divisions on the vernier scale. This will be further illustrated during numerical. And this extended vernier is used when the divisions of the main scale are very close and it becomes difficult to judge the exact graduation where coincidence occurs, right? So we use extended vernier when the divisions on the main scale are very close and it becomes difficult to judge the exact graduation where coincidence occurs. And the vernier graduations are made larger than those of the vernier of the normal length. In what case of a vernier? In an extended vernier where n divisions of the vernier scale correspond to 2n minus 1 divisions of the main scale, right? So this was about the verniers and the special type of verniers wherein we studied about direct vernier, retrograde vernier, a double vernier, a double folded vernier, and an extended vernier, which is used, let me tell you once again that we use an extended vernier when the divisions of the main scale are very close and it becomes difficult to judge the exact graduation where coincidence occurs if the vernier of the normal length was used, right? So this completes our vernier. Only the theory part, the numericals will be done in other lecture, which will follow from after this lecture. So we are on the last topic of the chapter. Now we'll study about duties of surveyor. Let's recapitulate the discussions as held in the video lecture number 1 on the topic, wherein I told you that surveying is the science and art of determination of the relative positions of the various points above, on or below the surface of the earth by measuring angles and distances, either horizontal or vertical. And who takes these measurements in the field? A surveyor. And then what he does? He does computations in the office and prepares plans and maps in the office, right? So the basic objective of a surveying is to survey an area and to prepare its plan or a map. Now, what are the duties of a surveyor? He should plan his work systematically. He should work carefully and accurately. He should plan his work systematically. The second one is that he should work carefully and accurately. The third one is that he should record the observations in neat and orderly fashion, because recording the observation is very important. He must do that in a neat and orderly fashion. The fourth duty of a surveyor is that he should know the relative importance of various measurements and he should develop some sense of proportion as to what is important and what is not. Right? He should develop some sense of proportion as to what is important and what is not. The fifth duty of a surveyor is that he should have the essential habit of checking measurements and calculations. Because no measurement is reliable if it's not been checked properly. Please note that. Habit of checking measurements and calculations. Right? So this was about some duties of the surveyor.